Hi everybody, welcome to Unit 4, Lesson 2. Today we're going to be talking about rates, okay? So you've probably heard that word before. Maybe your parents have said it, right? What is the rate? There's lots of different ways that rates are used in our real lives, so it is really important for us to have an understanding of them, okay? So a rate can also be thought of as a ratio. It's like different kinds of ratios. And a ratio is a comparison between two or more values. And there's different ways that we can write them. We can write them using the word to. So like here I'm comparing 3 to 5, right? So you can literally just write out the word to. You can also write them as a fraction, 3 to 5. It's still read the exact same way. Or you can use a colon, which mine doesn't really look like two dots, but that's what that would look like there. Okay? So we're just going to go straight into some examples, and let's get going. I got two right here. So number one, write a ratio comparing blue dots to red dots. So notice I said the order that the ratio should come in as well, or the rate, but I said blue to red. Okay, so that means I need to count blue, which in this case is 4, and compared to the red, which is 5. So I could say 4 to 5. I could write it as a fraction. I could also write it using the colon. So it is important for you to pay attention to the order that it presents it in. If it had said red to blue, I would have had to flip those. I would have said 5 to 4. Okay, so you do need to pay attention to that throughout your lesson. Number 2, give an example of an equivalent ratio to 7/5. So notice I wrote it as an improper fraction in hopes that that helps us to understand that just like with fractions, when we reduce them, right, then we still have equivalent fractions. Well, the same thing is true with ratios. So as long as I am performing the same operation to the numerator and the denominator, then I'm keeping it equivalent, okay? Or I'm keeping it balanced. So I'm just going to make something up. I'm going to say I'm going to multiply both of these by 3. Because I'm doing the same thing to my numerator and my denominator, I'm keeping it balanced, I'm keeping it equivalent. Well, 7 times 3 is 21. 5 times 3 is 15. So the ratio 7 to 5 is equivalent to the ratio of 21 to 15. Okay, I could have multiplied by 2, I could have multiplied by 100. It doesn't matter. As long as I'm doing the same thing to both, then I'm creating equivalency. So we could go the opposite way. Now this can't be reduced. 7 and 5 don't have anything in common. But let's just say I had the ratio of 14 to 10. Well, I could have done the opposite. Like here I multiplied. I could also divide, and I'm still creating an equivalent ratio. I can recognize, okay, both of those could be divided by 2, which would get me back to 7 over 5. All right, so either way. All right, last one for today, number 3. This is from your quick check. All right. Nico has a jar of candy containing strawberry, butterscotch, and root beer flavors. Yum. If there are 10 strawberry, 13 butterscotch, and 7 root beer candies, which ratio shows the quantity of strawberry candy to the total? So I chose this problem to go over with you because there's a few important things. One, it told us the different types, right? But the actual question, it says we want to know strawberry compared to the total. Now, I wasn't given the total amount in the problem. In order to find the total, hopefully you recognize, you'd have to add them all together. So to find the total, I would add, let's see, we had 10 strawberry, 13 butterscotch, and 7 root beer. So, and when I add those together, I get to 30. So my total is 30 candies in this jar. Strawberry flavors are right here, 10. So if I'm making a ratio comparing strawberry to total, I need 10 to 30, which in this case is this answer here. So ratios, in this case, it's a part to a whole, right? I'm comparing a part of the group to the whole group. You could also compare whole to part, or you could compare part to part. I could have said strawberry to butterscotch, and in that case, that would have been here, 10 to 13. So there's lots of different ways that we can present ratios, but it all depends on the wording in those problems, okay? So I hope that's helpful, and if you need extra support, just let me know.